And welcome back. In this lesson, we're going to talk about classifying matter. Learning target is on the screen. We're going to organize matter into different categories based on their chemical and physical properties. If this video goes too fast, you can always pause it or access the master notes. And away we go. So matter can be sorted into two categories, and then those categories can then be further split down. So let's take a look at that. The first category is pure substances. They always have the same composition. For example, water is always H2O. If you have H2O2, that is a totally different compound. And so pure substances can either be elements or compounds. Here are some examples. And so now we're going to take a look at what makes up an element, what makes up a compound. Elements are a substance that cannot be broken down into any other substances by chemical methods. If I break an element down past the point of being an element, we're breaking it into subatomic particles, and then it is no longer able to exhibit those properties that make an element unique. So, examples of elements would be iron, aluminum, oxygen, and hydrogen. Take note that even though there are two oxygen or two hydrogen, those are elements because there's only one type of compound, one type of thing there. These are special. There are 5 other ones. We call those the diatomics. They always exist as two, but they are still elements. So even though there are 2 of them, it's an element, not a compound. All matter in the world around us contains elements. So everything is made up of these base substances. The next is, here's a picture of what elements might be represented on a atomic level. So here is a picture of an element. Here's a picture of an element, but it's those diatomics. So these are actually molecules of elements. Atoms are the smallest piece of an element. Many atoms together create something that you can see. If you break it down into just one atom of the element, that is beyond our visible scope. Compounds are substances that have a given combination of elements, and you can break compounds down chemically into those specific elements. And so you can take water and break it into hydrogen and oxygen. And so that's kind of the difference between elements. If you break H2 down, you're breaking it past that atomic level. But if you break water down, you can break it into those different components. So water is an example of a compound. 2 capital letters in a formula is kind of an indicator that you have a compound. And so here's carbon dioxide, and then this is sugar. A compound always contains atoms of different elements. Carbon and oxygen, hydrogen and oxygen, carbon, hydrogen, and oxygen. It always has the same composition. Water is always H2O. So now we have this side of our matter chart, pure substances, and we have 2 categories. So now let's look at the other side. Here's a picture of what a molecule of a compound might look like. So breaking it down into attached pieces of different elements. The next is mixtures. These have a variable composition. That means it can change. So examples would be wood, wine, coffee. They can be separated into pure substances. So you can take mixtures and separate into elements and compounds. Mixtures are made up of 2 or more pure substances physically combined, meaning there is no joining, it is just physical combination. Here is kind of a picture representation. Here we have 2 elements. There's your diatomic, there's your regular, and then you have a compound as well. There are 2 types of mixtures, and so the first type is homogeneous. The prefix homo means the same, and so this means it's the same throughout. It consists of visibly indistinguishable parts. You cannot see the different pieces. When you look at wood, you cannot see the different, not wood, sorry, gold. You cannot see the different pieces that make up that jewelry, because gold jewelry is made up of different things for strength, but you can't see the other metals that are involved in making gold jewelry. A solution is a homogeneous mixture. A solution is when you have two things mixed together and it dissolves. So, salt water, sugar water, iced tea, coffee, those are solutions. It does not vary in composition from one region to another. If you're drinking a cup of tea, the first sip tastes just like the last sip. So, air is a homogeneous mixture. You can't see the different compounds and elements that make up air. Brass is another metal that is a combination of um, two different elements. Table salt stirred into water, again, sugar into water. So, homogeneous, the same throughout. And the next type of mixture is heterogeneous. This has visibly distinguishable parts. Now we can talk about wood because you can see the different grains and the different makeup of wood furniture or even a tree. It contains regions that have very different properties from other regions. Oops. I like to think of salsa as a heterogeneous mixture. You have tomatoes, you have onions, you have cilantro, and you can see the different pieces and you can separate them fairly easily. So, oil and vinegar is another example. And sand. So, when you put sand in water, you can see the different pieces. It settles to the bottom, um, and so it's not homogeneous, it's heterogeneous. So we will have a lab activity on Monday that will encompass kind of doing the pictorial representation of mixtures and pure substances. So if you have any questions, write them down or send me an email. And until next